Hey guys, how you doing? Hopefully you're doing well today. And this is our sixth lecture in the first section of Introduction to Sociology. And just as Shaggy, the sociology dog, he just drops to drop in to say hello. Hey Shaggy! Shaggy just had a bath today, which is why you're able to see him. Normally he's pretty dirty. All right, Shaggy, that's enough. Get up. All right, so in this class, we're going to discuss the scientific method. Yeah, no, I mean, come on. We shouldn't use rude words like that, Sherry. Just because you love science doesn't mean you're a nerd. So what is science? First of all, some popular misconceptions. A lot of people just assume science means the same thing as technology, lights, cameras, lasers, things like that. That's not true. Technology is the study of techniques, how to get things done. And this has been around forever. The first cave woman making the first fire had technology. That was technology. And we've developed technology throughout human history without science, per se. People have used other techniques, trial and error, patience. So science is a very specific method for studying the world around us. Second misconception people often have is that science is about proving what we believe. That's not true. Science is about questioning what we believe. So it's a very different method, and that's what makes it different from every previous method in history. So, first of all, science is a method for questioning our understanding of reality by using falsification. What does that mean? Let's assume that I see all the time white swans. I only ever see white swans, so therefore I believe all swans are white. Now, how many swans do I have to believe to prove to you that all swans are white? You see, this is the problem. When you take a positive approach like that, it doesn't matter how many white swans you see, it doesn't prove that there are no black or red or blue or green swans out there. You're just piling on evidence that adds to your case, but it doesn't prove it. So instead, in science, we use the opposite technique. We set out to prove that we are wrong. So if I believe that all swans are white, then I set out deliberately to look for a swan that is not white. And the harder I look, and the more systematically I look, and I still don't find a swan that is not white, therefore I can be more confident that all the swans are indeed white. Now note, I do not say prove, because science does not claim to prove anything. It only claims to question. And when we come back, we say we have 99% or 99.9% confidence that we are not wrong. Right? That's the difference between science and every other method of searching for truth, which usually is a simple affirmation, I believe. The problem is, if you believe something, there's no way ever to prove you're wrong as long as you believe it in your head. Second point, science uses logic to frame a testable hypothesis. So you start with a research question. Let's assume, let's have a question like, are people who attend church really more likely to go to heaven? So what's my theory? Let's say, based on logic, right, millions of people believe that they're going to go to heaven if they follow the right process. So logically, let's assume they're right. Then I formulate my hypothesis. Now, hypothesis is a specific and measurable prediction based on my theory. So look at it, hypothesis, right? It's a part of the thesis that we're going to prove, or at least test. So, question for you. Which of the following is a good hypothesis? 1, I will ask religious people and they will say this is true. 2, I will ask a random sample of churchgoers and most will say they will go to heaven. 3, I will take 100 dead people and see that the ones who attended church regularly are in heaven more than those who didn't. Got it? So you should have paused it. Let's look at them one by one. First of all, I will ask religious leaders if they believe this is true. Well, the problem here is that obviously religious leaders may be biased. If they're going around telling people, come to church and give me money and you're going to go to heaven, they're not going to tell a researcher that something different, right? So they may not answer honestly. Number 2, I will ask a random sample of churchgoers if they will go to heaven or hell. Now this is more direct, you're going straight to the churchgoers, but you're asking them about their belief, not about what's actually going to happen. So if our question were about their beliefs, that would be fine. But since the question is about whether or not they will go to heaven, then asking them what they think will happen is not a way of answering that question. All right, third one. I will take 100 dead people and see if the ones who attended church regularly are in heaven more than those who didn't. Now, this will actually directly answer the question, but there's a catch. Can you guess what it is? Yeah, dead people don't answer questionnaires, right? So good luck getting your answers on that one. So that's a hypothesis that you cannot answer. So face it, not all questions can be answered by science. So science started off perhaps to look at the world and how wonderful it was and to prove that God existed. But this is the problem. Science relies on empirical evidence. The hypothesis must be tested using something we can see and feel and test in this world. Right? Secondly, it must reflect the question. And it also must be something we can see objectively without bias. Right? So there's going to be a lot of questions you cannot answer scientifically. Is there a God? We don't know, or at least science cannot answer that question because God does not answer questionnaires, and he doesn't leave direct evidence of his existence. Right? What we have is a lot of stories, and they may or may not be true depending on your belief. But there's never scientifically been any way of verifying any of those stories. And even if we did, even if there is evidence of one of the stories, that doesn't prove that there was a God who did it. So these are the limits, if you want, of science. Science can only deal with the real, physical, tangible world around us. Logic. Now, the logic of social science is one in which we assume a cause and effect relationship between the things we're interested in. We call them concepts. Right? Cause and effect. So, for example, racism. Racism didn't pop out of thin air. It was caused by something. Inequality. People are not pop out unequal. Inequality is caused by something. Marriage, love, hate, all of these things have causes. They don't just happen by themselves. So we do not believe in spontaneous generation. We believe that everything has a pre-existing cause. So everything is an effect of something else. Secondly, the logic of social science is that we can find the cause of a social action or effect through careful observation and measurement. So think of this. When we're examining causality, causality is the process by which one thing causes another. We use essentially an if-then statement. If I am hungry, then I will eat. Right? So what causes me to eat is my hunger. Right? One thing causes another. I studied hard and then I did well on the exam. Right? So I studied hard and that had the effect of me doing well on the exam. A difference in one concept, in this case studying, causes a difference in another, in this case result on an exam. Now, notice that this claim, or these claims, are probabilistic, because we don't know all the things that may affect how you do on the exam. It may be that you were well rested as opposed to tired. It may be that you drank a cup of coffee as opposed to a cup of cocoa. It may be that your friend sat next to you and helped you understand the answers. Right? So when we make any claim, we never make a total claim. We think of things as more likely to happen. Right? So people who study harder will tend to do better on the exam. It's a probabilistic statement. Another thing is we use inference. Inference in a couple different ways, but to infer means to assume in a certain sense that something is there because of something else. Right? So usually, for example, we cannot see most concepts directly. So what we see very often are a specific case, or we see specific evidence of something. For example, we don't see study giving you a higher score on the exam. Right? So study is not a physical property. It's an action. Right? So we can see you study, and then we can see whether or not you did better on the exam. So we have to infer that the studying is what caused you to do better. Right? So inference means you are making an assumption that these things are related. So you have to justify that assumption. You don't see, for example, poverty. Poor people are more likely to have premature babies. This is true. But you don't see poverty going around giving people premature babies. But we might notice poor people are more likely than non-poor people to have premature births. So this is an inference. We can infer from that the assumption that there's a relationship, that poverty is causing premature births. So how do we do that? Evaluate these three statements. My wife took a blue pill and now we have a baby boy. Yay! Right? So the inference here, the assumption is blue pills create boys, right? That's what he's telling you. Take a blue pill if you want a blue boy. I'm sorry, a boy. Another statement. My son practiced for 10 hours and he hit a home run. Right? Inference, practice makes you a better player. Number 3. Fred took my business card and now he's a millionaire. Inference, my class, not card, my class will make you rich. Take my class in sociology and you'll be a billionaire, that's for sure. So, scientifically, which one of these statements is more likely to be true? Now, if you said number 2, you were wrong, because all of these statements are anecdotes. They're stories about a single case that might just be a coincidence. So even though number 2 sounds more logical, right? It doesn't sound logical that a pill's going to change the gender of your baby, and it doesn't sound logical that, well, it sounds more logical that that practicing hard will help you make a home run. Still, it's still an anecdote. An anecdote means a story about a specific case. Now, you'll hear people use anecdotes all the time. Politicians use the time. They'll say, here's Fred here. Fred took my program and he benefited and he's now so happy with his life because I got elected. So vote for me. Right? So that's just taking one case. You have to look at a wide number of cases in order to justify an inference. Now, we call this a correlation. And a correlation is when you use a large amount of data and you see that there's a systematic relationship between the concepts that you're interested in. So how do we establish this causality? How do we feel confident that there is actually causality. Right? So there are three tests, three things we ask ourselves in order to justify an inference of causality. So one, that the observable variables are correlated. So if we see over time, we evaluate maybe 100 poor women and 100 non-poor women, and we see that the poor women have more premature births than the non-poor women, right? And if we're systematic and we're unbiased in our observations, then this will help us to justify an inference of causality. Secondly, the cause must precede the effect. So in this case, we must show that the women were poor before they had the birth. Right? Sometimes you have a baby, it's expensive, and you become poor. So we have to show the cause preceded the effect, because logically something cannot be caused by something that comes after it. Thirdly, we have to make sure there are no other factors, a third variable or a third factor or concept that is affecting or causing both of the things we're looking at to happen. We call this a spurious correlation. That is, a correlation actually caused by something we did not see. So, we'll come back to that in a minute. Research concepts, variable. Let's clarify what this term means. Any concept, so we use a lot of concepts, and the point is, does the concept vary, or can it vary within a given population? But by population, we mean the group of people we're interested in studying. So, for example, if we're interested in studying boys in a boys' school, then boys, that's our population. What would the variable be? Maybe how often they practice soccer. Right? So some practice 1 hour a week, some practice 20 hours a week. So it varies. There's a difference. All right? So here's an example. Draw a box like this. So it should be a table that's 5 by 5. Right? And then write in at the top gender, age, race, eats food, and along the side, best friend, parent, teacher, me. Right? So what you have is you have 4 cases, and you're going to have 4 concepts. Right? So you can pause this video while you're doing that, no problem. And in the meantime, I'm going to go ahead. So what I want you to see is then fill in. So for example, your best friend, what's the gender? Male, female. Age, go ahead and put their age in. Race, go ahead and put what you think their race is. Eats food, yes or no. Simple enough, right? Parent, same thing. Teacher, same thing. Me, that means you, not me. You, same thing, okay? Now, I hope you had time to do that. Now look at your table, and you'll notice that some of them are different, and some of them are the same. Right? So, for example, gender, maybe some of them are men and some are women, male and female. It could be that all of them are male, or all of them are female, right? Depending on who you happen to pick. Age, well, almost certainly ages are going to be different, right? For a start, your parents' age is going to be different from your age. Right? Race, well, again, that may or may not be different. It may be that everybody in your group that you're thinking of is the same race as you. Or it could be that they're different races. What about the last one? Eats food. Well, for sure, they all eat food, right? Here, I'm pretty much sure that that's true. No matter how little they eat, they still eat some food, right? So what's the point here? The point is, some of these are variables. So if we have a variable, we can say something about its relationship with another variable. But we cannot say anything, for example, here about eats food. Can I say that older people eat more food or are more likely to eat food? No, because everybody in your sample eats food. Can I say men or women are more likely to eat food? No, because everybody in your sample eats food. So in other words, eating food is not a variable in this model, right? So you can't really say anything about something unless it is a variable, right? Unless there's variables. Now, if you had, instead of eating food, you could say, is a vegetarian, now that then might be a variable, and you could say something about it with relationship to the other variables. Okay, so thank you very much. I hope you enjoyed this lecture. I'll see you around the block at the next lecture 7. In the meantime, make sure you look over the companion for review and any other assignments.